So, okay, let me try another device. So this is Windows, my laptop, and I'm gonna recording here. Let's continue doing the kth largest element in an array in this book, in this uh, place, and use another function to do that. Like we use the heap. We right now have to um, build a heap by ourselves. Okay, let's get started. How can we um let me show you my scene. Sure, that's correct. It might be correct. Okay, let's have a try. So you can see my browser, right? The Chrome, I'm sorry, the Edge, Microsoft Edge. Okay, so this one, right? I don't know why it's. Maybe we can add a stopwatch, whatever. So still, you know. Okay, let's continue doing. Actually, I don't know how to build a heap by myself. Let's get a reset. And as you can see here, this this problem is in the set of the heap and the priority queue. So if we want to, you know, finish all of these three tasks, we have to know how to build it. So, but the, you know, quick selection or quick sort part, I don't think I can exercise on these three tasks. Who knows? I don't know actually, so it's not the task right now. Okay, let's just build a priority queue. Use a heap. As I know, heap is always uh the two what tree to side tree. How does let's check. Uh, let me find a what do we call translator? TRAANS transformer. Binary tree, yeah. We always use binary tree to implement a heap. How to say? What's wrong with that? How to say? Accomplish, implement. Okay, usually use binary tree to implement a heap. And as we can see here, we use the I remember, actually, yes, in my digital garden, I truly remember I mentioned that in this, I'm sorry, not this part, this one. So the Min-Heap. But if we want to find the case largest number, we have to use the what's this max heap? How to translate? How to translate this? Max heap. Okay. Yeah, we should use. Oh, so we want to find this, right? So we should use a min heap. The key case case largest use min heap and the case smallest use max heap because we have to delete the smaller number and leave the greater number. Not greater, it's a larger number. Yes. So if you find a new, I don't know how to do that actually. I've never code a heap by myself, but we have to do that. So I think let's firstly ask AI how to do that. Oh, this is good. Hmm, let's see. It's not this one, but this one. Let's ask first. Priority queue. Oh, we can maintain a fixed. We can maintain a main heap which has a fixed con, container K. Uh, how to say this? Capacity. Ah, yes, which have a fixed capacity K, fixed or the constant capacity K, and traverse. All right, traverse. Iterating.
Iterating through an array.
Iterating is another, but traversal. This is a noun, not a verb. Iterating, whatever. Iterating. Okay. Okay. Iterating That makes sense. That makes sense. So let's talk about this in English. We can maintain a mean heap, which whose capacity is k, and we iterate the array and push right, push the number inside it. Once the once the capacity is greater than j, we pop out, right, the top, the heap top, the how to spell this, top of the heap. We pop. Actually, we pop the smallest element in this heap after the traversal. Uh, After the traversal, the top k numbers will live in the heap, and the top of this heap is naturally or automatically the smallest one in these k numbers. So this is the answer, the k's largest element. Okay, I definitely understand that. So so Java have priority queue, Python have what's this, heap queue. C++ have standard library, but we don't have that. So actually we have to use this. Class Min-Heap, private heap. Oh, okay. Can I directly suppose that there is a min priority queue class? Can I assume that a min priority queue class is directly available? Ooh. Actually, we have this in LeetCode, but we might don't have it in the interview. Interview. So we have to write this, and the interviewer wants to see we have ability to code by ourselves. So we still have to write this class. This is okay. Let's build that. How to write it down? Class in this closure. Clo closure. Closer. Hmm. Let's see if it works. How to write that? I don't know how to write. Oh, okay, bracket and private private heap. So there's no let or const in this, right? Maybe we have, but I don't know. Push pop peak size. Or size is a function, not this heap dot length. Also, size is a function, not a. I mean, there are two parts in class. One function and another one is called variable. Function 方法，另一个是变量。Not variable, but variable.
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 Okay, variable. 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 Okay. So we built variable as private because we don't want others to see that variable. Let's build a private variable. Variable. Called what? Called heap. Okay, makes sense. Heap. And the type of the heap is that a type or oh yes, the type and the the assignment. Why we call it the assignment? uh, type and assignment. Okay, assignment. This is type. Uh, heap has a number array and assignment an array. Do we need to add a what do we call it? Semicolon?
Semicolon.
Semicolon. Oh shit. Semicolon. Okay. Do we need that? Sorry. Semicolon. Yes, we need that. And let's define some functions. So first one is size as a function which will return a number. Actually, I think I can use the arrow function here, right? Oh, I can't because arrow function don't have this pointer. This pointer point nothing, point itself actually. So no arrow function in class. Am I right? Maybe not. Some kind of, not the constructor function, but those, it's only a function like a pure function. it don't have side effect in class, which can build as a arrow function, I think. So whatever, like this, right? It's truly weird. Yes, I am right. So return the heap. So this dot heap dot length, right? length, length. Here this dot heap dot length. Okay. So another function called the heap, which will return a number, and the number is the first element in the heap, the top of the heap, right? So this dot heap, we have 0 here, and push. Do we have a let inside it? It should be const. No, nothing inside it. So we, whatever, we just call it we as a number, and we will uh we will do what? Oh, we will return what kind of data, what type of data, and drink. Um, what kind of, maybe I believe it's a boolean, but mm, maybe the number, right? I don't know. Void. Ow! Ouch! Void. Yeah, actually, I do not. Uh, Let me tell you my thoughts. Firstly, I think it should be a bowling, but I don't think that we have a failure condition in this truly simple class, right? So after that, I think I should return a number because push and pop, they are a pair, a couple. So push, pop, pop returns a number. I think push it should also return a number. Actually, I remember in C++ or in Java, in C++, in std, we have we also have push and pop, but both of these two functions are return type of uh, void void type. So this seems like a couple. So but every time you want to, you know, like pop and get the number, pop the number, you have to do the pick first. After the pick, you pop, and the pop returns a void data. That's truly weird. So actually, yes, I said before, this is a simple, truly simple, very little class. So yeah, we can return a number, but that's not necessary. So let's build void. Yes, you're right. And this. push, right? Push V and do the pop up. I don't know if this is correct. Shift up. Not pop up. I thought, bubble like like sinking down bubble up. Okay, shift up, shift down. Mm, shift up. Actually, it's not a shift, but a shift. What is shift? Oh, all shine绿. Come to. Sure, all right. Shift up. Let's use let's shift up. And in this thing, shift up. This have length -1. This is the index, right? The index of this value. So shift up, up. This dot with dot not the yes the index, the length -1. Okay, and pop uh return number type. And firstly swap the very beginning and the very. Let's have a look. Oh yes, these two sides. We should add these two sides. Cause the top is the number 0, heap 0, and the heap 0 is this dot heap dot pop. But this actually the pop will cost too much in the TypeScript. I always think about that. Hmm. Never mind, never mind. Let's just build it. This heap dot pop and then shift down. Oh yes, yes. You know, put the last element to the top of the heap and shift down. I'm confused on this point. I thought swap these two element and delete. Oh, that's the same. We're the same. Oh yes, we have to uh, save the number in this top. So firstly, some boundary conditions. Yes, boundary conditions. Hmm. What if this dot hip dot length is zero, right? If it is zero, then we return an error code, whatever it called error code or something else, right? And what if the length is one? If this one just return the first beginning, right? The return, yes, this dot pop. As you can see here in the JavaScript, we have pop and push and also shift on shift in the array. But we actually return the number in the pop. That's actually more meaningful. I think, C++, the STL. STL means what standard, what kind of library. That library use a lot of, thoughts in I think in the, what do we call that? in the设计模式，哎，这词是啥来着？Not design importance. Let's have a look. Oh yes, actually the design part. Yes, yes. Standard library use a lot of this design patterns,
Design patterns.
design patterns, and it's you know some of them are totally meaningless. Yes, it have less side effect. It's almost a pure function, but I don't like that. I don't like that. I like this. Truly meaningful, right? Pop, just give me a return, give me a response after you pop one element. That's the, so I truly like this. But JavaScript and TypeScript, the main core, they don't have vector like C++. They don't have, you know, stack. They don't have queue. I was always wondering why. I thought, uh, I remembered this, standard library for JavaScript is now in oh, why do we close this? Sorry. What do we call that? Con conference is now in 会议提案 Proposal. No?
Meeting proposal.
Proposal. A proposal. Yes, in the conference proposal for those ECMA script. Uh, what do we call that? Yes, they are right now in there. Maybe we can use that not in some days, you know, without using a third party library. But actually some third party libraries are truly helpful and powerful. Like those Ludash. Ludash. I remember that library have a lot of function like this and a lot of function like sort, like format date. Actually, I don't. mm, I've never used that one. I use that library in my program project, but the code is generated by AI, and I think, oh, that's work. That's not that's meaningful, as I in my view. So I don't use it. I've never used it. I've never used it by myself. I never read the document about the Lodash. I never watch the videos about that. Mm. What I'm doing, I'm LeetCoding, right? So after that, we have to see. So let's count the answer as a this dot if dot the heap zero and swap, right? But we don't need to swap. We just need to put this in to the top on the top of the heap. Ah, is that right? And we 运行 execute a read 调用，这些都怎么说啊？嗯，哼哼嗯，on call 是 call 的 function。嗯，然后 run 哦，run 的 function，哇，run。Okay, I remember that. Let's run this function shift down as the index this index zero, right? Yes. And after that, return the answer. Okay. So another top. Okay, top. Top is uh, symmetric. How to say that? Symmetric, semantic,
Semantic.
semantic. Ow, top is more semantic. Okay, maybe we have to build this to private functions right now to finish this class definition. So firstly, private. Is this not a really? It's just at the never mind, never mind. The sit that's right. And we want it to return a while, some sort of that, right? Index. I forgot about index. These two are all void. So what's this? Right now we are building the Min-Heap. So when the element shift up, we have to compare it with its parent. If it is greater or equal to its parent, then it can stay here. Otherwise, it have to shift up, right? Right? Yes, I'm a genius. Oh, and we have to think about the boundary condition. So the the boundary condition is the index shift up to the top of the heap. After that, the it we we don't need to shift it up again. Yes, yes, you're right. So we contain the logic into a while loop. 包裹 not a pack actually. Bind up. Mm, encapsulate. Let's look about this. Right.
封装 encapsulate.
Encapsulate. Let's encapsulate all the logic in a while loop. So the while and the condition boundary condition is must have master greater than 0 and uh what's next? Check if the not heap If, oh, first need to find the parent. Never mind. Find the parent. What's a parent? What's a function? Oh, we should find the parent index. Not find, just calculate the parent index in the binary tree. Mass floor index minus 1 divided by 2. The at the mass floor. This, like, we have to remember this in the LeetCode right now. So we put a floor, put the floor of index minus 1 divided by 2. So this is a parent index. And let's compare with this two. The heap index and the heap parent index. If the heap index is less than the heap parent index, we should in a swap these two, right? There's a comma here. This is comma, right? This is comma. Okay. Comma.
Comma.
What about this is semicolon.
Semicolon.
Semicolon. I can't remember this. How about 句号 period 一段一段
Period.
period
Period.
period period 还有什么引号？引号是 bracket parenthesis 不是哦 quotation marks
Quotation marks.
quotation marks okay oh yes quotation marks question mark and 感叹号
Exclamation mark.
Ex- exclamation
Exclamation mark.
exclamation mark uh, oh you can see the dictionary we don't have a Chinese English Chinese dictionary here a sudden cry or remark especially experience surprise anger or pain a sudden cry exclamation exclamation
Exclamation mark.
exclamation mark an exclamation mark okay oh so yes I remember that we need to use exclamation mark here oh and also here right we have to hop that we have not pop but Uh, add it here. I remember there is a, what do you call that? Excla exclamation mark.
Exclamation mark.
Exclamation mark. We have this right here. So use the this hip hop. Oh, you're right. You're right. Pop. Oh, so we always use an array. Actually, we only use the pop and push. We don't use the shift. I'm confused. I make a misunderstanding. Oh, right, right. We only use pop. So pop it will only cost one of time complexity in the JavaScript. That's truly acceptable. Mm. Uh, so swap, right? Swap here. Oh, okay. Swap, and what's next? And that's all. I think that's all. Am I right? This dot swap. Where do you find this? Do we have oh, we have swap function here. Why we need a swap function here? Maybe we use a lot of swap inside of this, but actually no, there are only two swap here. So we don't need to remember we have to write a function like this because this is the basic swap sentence in the JavaScript. Index is parent index. Oh, we have to update the index. Yes. And let this index go into another circulation. So index equals to actually we have a spelling error here. Writing mistake. Writing mistake here. Yes, I think that's all. And if less or equal to, the parent one less or equal to the current one. So the current one less than, yes, we have actually the good logic. And the next one is right Shift down. We use index here as a number, and let's return a one. So the logic inside of it is, I mean, shift down. Maybe, yes. Firstly, let's get those two uh children. Get the children of the current node. But remember the length and how to break that. If the main index, hmm, oh yes, inside here we know length, so we can check if the left or right child index is greater or equal to the length. It's out of the scope. How to say 超出范围 out of range. Yes,
Out of range.
out of range. Range. Out of range. That. What should we do? Let's see. Okay, firstly to get the to get the length of the heat dot length, right? And if not if, let's say we have to use a loop. Let's say a while loop. Or give me the true, true, and we will break after the comparison, right? So firstly, do the comparison, compare, comparison, comparison, comparison. Okay, compare, comparison. First to the compare. First, we have to calculate the index. So there are two index here. Left child index is what? 0, 1, 2. I remember the index times 2 plus 1. Yes, this should be right. Let's say 0, 1, 2, 3, 4. So times, okay. So here we got right. Let's try. Right is plus 2. And we have to find the minimum number in this 3 and put this minimum number into the parent location, into the, yes. So just gotta mean, is that the protect, what do we call this? 保留字符是吧？Reserved character keywords or keywords. Yes. Can I use this? Actually, yes. We can use another semantic name, domain index. You're right. It's index, right? And to it, to check, to swap if you find mm, the index of the mean number, minimum number, mean number that's acceptable. Mm, if this one very long name less than less and the the what the heap this one is less than heap index. Then we have to swap. Not swap, only change the uh this not the this one but the mean index. Actually not the mean index but the heap mean index. This mean index not means the index is mean, but means the value in this index is mean, right? So let's change the main index to this index, and the same to the right child index, right? Right child index less than mean, and the heap right child index less than heap mean index. So update the main index. After that, if the main index is still equals to the index, that's great. That makes sense. And what's the next? Next is to swap. Yes. Swap the what? The main index with the index and update the index. Let's just copy the swap the sentence here. There are some, you know, some wrong in my mouse. Whatever main index here. Let's yes, and update the index. Right? Yes, that's right. And I think that's all. So main index the break this web index is main index. Oh, I forgot this here. So we have to add the scope this. My mistake. So we can use this class right now. The class here, this line, and key is the largest element. So we have to new a key, right? Const heap, not new a key, and new heap. We don't have a for constructor. We don't have a constructor because we don't need to. We don't need the initial like initial. Yes, we don't need initialization. Yes, so new a heap and traverse. Yes, traverse every element in the nouns and so we have to like if the key is 2, the size must be 2, right? Am I right? Or let's say just a const v of the nums, right? So the next one we will return heap dot pick whatever pop, but pop is more expensive, so we choose pick and v, right? If what? If v is larger, right? V is larger or equal. Uh, that's meaningless or equal. So larger than heap dot peak, we have heap dot push the v, and after the push, if the size of the heap dot, you see that after we finish the not destination, the definition. After we finish the definition of a class, we are truly easily to use this. After the 分装怎么说的来着？encapsulation,
Encapsulation.
encapsulation. After encapsulation, encapsulation. Okay, if the size of that, right? The size is greater than k. Yes, no problem. Greater than k. Not that too. Not than k. Then we pop. That's all. No, undefined. Why it's undefined? Size this dot peak 0. If this is an And should I add an if here? No, because if there's not uh, if it's 0, it will return an undefined. It will return an undefined. So the number, we should add another type undefined. So we should add a, what do we call that? Exclamation. Exclaim. 哦，这是感叹的意思啊。Exclaim，原来如此。Exclamation，把一个 I 去掉，exclamation mark。
Exclamation mark.
Now let's check about it. No. So let me ask. Is this an assert? I don't know. And let's check why Min-Heap.pick as Min-Heap use none of nouns. Push if it's k, then pop. And let me ask if. Oops. Okay. There's two questions. So firstly, why there is no exclamation mark? 非空断言操作符 non null assertion operator 啊。Oh, that's because the pop function return two types. So we have to add an assertion. Oh, why? It big is only fine if we let's have a look. Why did I write this? Oh, that makes sense, right? Oh, but I forgot about that. Also, brick is important. I forgot that. Oh, so how to fix this? Ah, yes, the true logic is. So the first delay, hmm, oh, that makes sense. Let's have a quick look. So let's fix the block 2 and block 3. So here, the clip, right? Uh, uh, oh, yes. Mm. This is the reason we have a swap function in the previous part. That's truly a lot. That's truly a lot. And here we have the dead circulation, circulation. Yes, the dead circulation. We have to break here, right? And put this to here. And let's how to say that for for that 4 more times. Well, hmm, this is good. So this should be, true, but because of uh the the boundary condition, we have an index greater than 0 here. But actually, we can put it into here, right? Change this to true and put it into, oh, yes, before the swap. So before the swap into here, yes. So they are like the couples. That makes sense. Cool. Oh, yes. Oh, boy. Everything should be right this time. Okay, let me ask another question. Let me just submit and ask another question here. Oh, yes, we have to thinking to level. How do we? Oh, the running time is not acceptable. Stage yeah, stage one. So there are two stages. So first stage is the this one. Oh yes, the size should be in the outside of the peak, smaller or equal, oh, smaller than push, equal not push, and but else peak not peak. If we exclude then then we push and pop, right? Or first we pop then push. Oh, first we pop then push. Okay, let's say if we can get here. Oh, but actually this is because another reason is we build a heap. We build a Min-Heap, not use the like main priority queue in the LeetCode. So the speed, the 性能 performance, oh, the performance is not good. Oh, we can ask Gemini about the question. Heap.replace. This is good. I'm going to, put all of this into our digital garden. Oh, this is pretty good. Replace, so it will not cost too much. You see that max heap? Max heap. Max priority queue. Max heap in queue and then DQ. Hmm? Then DQ key elements. I see. Oh, this is sort. You see that? Sort? Hmm. This is a handmade heap. Oh, this is truly quick. This this do not have the boundary condition checking, so it goes very fast. That's not good. That's not good. Oh yes, I remember that this is a syntax handy get to 分光. I don't want to. What's this? Oh, the quick selection, but not for the reverse version. Hash new map. Use hash. What's this? Oh, that's another idea to put this array into maps. Maps is disordered, so there's no index, and we can take the uh, max number very quickly. And compare hash get. Never mind. Never mind. This should be the sort method. coming soon. Typed array. Typed array. Mhm. Oh, we don't need to write this function here. Wow, let's have a try about this. Oh, truly quick. It's quicker than before. I believe so. This is a uh, sort function. Yes, this is a sort function in what we call structured array. Typed array. Okay, got it. Incredible, huh? Incredible. So I think that's all. You can do the questions tomorrow. Sure, let's see you guys. See you guys.